Hello, welcome to my channel. My name is Loange, and in this video we're going to deal with multiplication of a vector by a scalar. Okay, so this is one of our videos devoted to a series on vectors. Good. So if you are new to my channel or this is the first time you're joining us, please you may have to go back to the previous videos just to catch up with us. But of course, if you've gotten the basics already, then we are good to go. And if you find this video helpful, please consider subscribing to my channel, all right, and then share with your friends. Good. So multiplication of a vector by a scalar, this is just like saying multiplication of a vector by a number, right, constant. Now it is very common for someone to say scalar multiplication as a way of saying multiplication by a scalar, but when you say scalar multiplication, it's not that good, because scalar multiplication actually means something else, where we say the product of two vectors and there are different products. We can have vectorial products and we can have scalar products, so we should be more careful with this. So I choose to say multiplication by a scalar. Good. Okay, so let's just get on with it. So we say if you have a scalar, maybe let's call the scalar c, that is a real number. Okay, that's a scalar, right? And a vector, let's call the vector v. Then the product given by c times v, okay, that's multiplication of a vector v by a scalar c, will be, well, let me kind of get this in piecewise notation. This product will give us a vector with size, you can say with magnitude as this. Now you note this notation, when we dealt with length of vectors, this was the notation I made use of to determine the length of a vector v. So if v is a vector, the length of the vector is given by that. Then I'm putting this c in absolute values, because when we want to talk about magnitude, we make sure that it's a positive number. This scalar could be positive or negative, right? So we have to put the absolute value to ensure that we do not get a negative result. Good. So this product is a vector with magnitude of that, pointing in v direction, pointing in the direction of vector v, in the direction of vector v. And this is so if the scalar we chose or the scalar we were given is greater than 0. In other words, if it is positive. So let's start again. If c is a scalar and v is a vector, then this product c times v, that's this multiplication of a vector by a scalar, is a vector with magnitude that is size as this in the direction of v if the scalar c is greater than 0. But what if the scalar is less than 0? What happens? Well, in this case, we say the result will be a vector with size, that's magnitude, with size as the same size. It will have the same size because we are multiplying it by the same scalar. Okay, but in this case, it will have the opposite direction. In the opposite direction, oh, let me write that properly, of vector v. So the case where c is less than 0, this will point in the opposite direction. You could ask what happens if c is equal to 0. Of course, multiply this thing by 0, the result just becomes 0. Could say the 0 vector. Anyway, so let's illustrate what this is. Okay, so let's say we have a certain constant. Maybe let's just choose a particular example just to reduce the ambiguity of the stuff, or the abstraction, right? Okay, so let's say we want to evaluate this. Let's say we have vector v and then we want to determine the following. So given vector v, okay, determine the following. Maybe let's say determine let's say first one we want to determine 2v. Okay, that's 2 times vector v. Then the second one we want to determine negative v. Okay, that's like say negative 1 times vector v. Then the third one we want to determine let's say 1/2 of v. All right, that's 1/2 times v. Maybe lastly we want to determine negative 3 times v, something like that. Good. Okay, so let's see, we could simply just drag this up a little bit. Let's be sure that we get it right. Okay, so maybe let me drag this one a little bit. Okay, that's nice. Now let's say this is the vector v that is given. If our vector v is like this, right, just simple, let me not make it too long because I will need to multiply it, right? Okay, it shouldn't be too short because I will need to take half of it. So if this is vector v pointing in that direction, we want to determine the first one, 2 times v. Now this vector will be coming from to this definition, it should have a magnitude of 2 times that thing. Okay, so in this case it's c times where that c has to be positive, that is the absolute value of c. So what we have to do is think about this vector, then you multiply it by 2. That means you have to double the size, right? So we want to double the size of that vector. Now it may not actually be the accurate double, but it should be nice enough since I'm just using freehand. Good. So double of that vector, that is 2 times the size of that vector, should be something like that. So this is 2 times v. So we've doubled that vector, right? Good. Now for the second one, this is negative v. That's like saying multiply v by -1. Now coming over here, we say if the scalar is c, so in this case the scalar here is -1. Absolute value of -1 is just +1, which means in this case the magnitude will be the same thing as the length of vector v, right? Since absolute value of -1 is 1. You multiply 1 by the magnitude or the length of vector v, the length will stay the same. But in this case, since this c here is less than 0 in the second case, it means that this vector will be in the opposite direction of vector v. So this is vector v originally, okay, trying to maintain the length, but instead of pointing in this direction, it will be pointing in the opposite direction. That means to be going this way, right? So this is vector minus v. Vector v should point in this direction, here as the terminal point and here as the initial point, but the negative will turn the terminal point to becoming the initial, and then the initial point as the terminal point. So it is the same size as this vector but opposite in direction. So that is how to determine that. Good. For the next one, this is 1/2 times the vector, that's 1/2 of the vector. Now the magnitude will just be half of the original vector, but the direction will stay the same because 1/2 is greater than 0. So we should have something like this. Since this is vector v, we should have something that's pointing in the direction of vector v, but this time half the length, that is half the size. Good. So that is half of vector v. Okay, that's nice. I hope that's clear enough. And then the last one, which we have the last one, that's the fourth one, we have vector v, but we multiply it by -3. Good. So in this case, the scalar here, which is c, in this case is negative. What we'll get will be a vector in the opposite direction of vector v, but we are going to triple the size. So what happens here is this is vector v, we'll have to triple the size, so it's going to be 3 times longer. All right, I think that's about right. Good. But in this direction, no, in the opposite direction, because the scalar there is negative. So this is like -3v. So maybe we could partition it into lots of v's. We could partition it into this v, we could partition it into this v, where this is v, 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 3 of them. But negative means it's going to be pointing in the opposite direction of vector v. So that is how multiplication of a vector by a scalar should be thought of. Okay, that's nice. Let's see if we should do a little more example. Okay. Well, the example here, maybe let's just do some kind of graph so that we can see how to actually determine. So let's do another example. Maybe let me say this is another kind of example that will help us. Okay, let's see. So we given this. Let's say if we have this vector v as, let me use this notation, 2, 3. We want to find 2 times of that vector. Good. So let's represent that. So we have 2, 3. So I'm just going to need the positive axis. All right. Good. So 2 is pointing in the I hat direction. So if this is 1, then this has to be 2. Then we have 3 is pointing in the j hat direction. So if this is 1, this has to be 2, and then this has to be 3. Okay, so the common point should be around here, and then we're going to take the position vector from the origin, okay, up to that point. Good. Okay, so we want to find out what 2 times vector v will be. Oh, let me reduce this. Sorry about that. Let me reduce everything because I'll need room, right, to double it, because doubling it will increase everything. Our vector is pointing like that. That's v. Okay, that's vector v. Good. Now we want to find vector v twice. That's 2 times of vector v. So this is what we'll get. We will get vector v and vector v again, right, to get 2 times of it. So this is what I'm going to do. I'm going to extend vector v by itself. Just one more extension. Good. Great. So that this entire length from here to here is vector 2v, right? So, you know, 2v is just going to be v twice, right? Good. Okay, so what now happens? So since we've increased the length, so the max should go like this. This was 2, it will now increase by 2 to 4. This was from here to here was 3, it will now increase by 3 because we've doubled it to 6. Good, which means that the vector 2v could be written out as vector 2v could be written out as a vector, position vector, with entries 4 in the I hat direction and then 6 in the j hat direction. Okay, so it is really easy to see from here by comparison 2v and vector v. You see, we've just doubled the entries. In the I hat direction was 2, now we have 4. This one was 3, now we have 6. So it simply tells us that if we have a vector v, which is 2, 3, or let me just generalize it. If we have a vector v, which is maybe let's say something like a, b, then if you multiply that vector by a scalar, let's say c times v, we could simply just say c times a, that is ca, then c times b, that is cb. Good. We could simply just do that, and then we get the result without having to draw the lines and maybe computer that works. Good. And from here we could introduce subtraction of vectors simply by multiplying the vector by -1, that is the scalar -1, and then we could add it to another vector. That is how to subtract. So this is okay. Anyway, we'll continue from there, and the next video we're just doing some examples involving scalar multiplication of vector by scalar and then subtraction of vectors as well. All right, thanks for watching.